there. Can you see me? Today we're going to be learning about polynomial functions. It's 6.1 in your textbook. So here we go. We're going to get started with some vocab. First word I want you to know is monomial. Mono means one, so monomial is one term. And that term can include a number, a variable, or a combination of both. So I'm going to give you some examples of monomials. A lot of times people think that a number by itself is not a term, but actually it is a term. It's just a linear term, or a constant term. It's one number. It could also have something with a variable in it. So 4x could be considered a monomial. It's one term. It has a number and a variable. But it can also have more than one variable. So you could have something like 5x squared y would also be considered a monomial. It's one term with a number and two different letters, and the letters have different exponents, and that's totally okay. Those are just some examples of what monomials look like. But we're going to be focusing more on polynomials, and the word poly means many. So a polynomial is many terms. So basically you can take all of these different monomials and create a polynomial by putting them together, usually with addition and subtraction. So this is the actual definition of a polynomial. This p of x equals a sub n x to the n power plus a sub n minus 1 x to the n minus 1 power, and the pattern continues. Eventually you get back to a sub 0. Now, that might sound kind of scary for some of you. That's a really ugly definition, but I want to show you that it looks uglier than it actually is. For example, let's just suppose that n equaled 7. When you look at this definition, it doesn't have to scare you, because we know that it would be x to the 7th power. The next term would then be x to the 7 minus 1 power. So what is n minus 1? What's 7 minus 1? 6. What's n minus 2? 5. What's n minus 3? 4. What's n minus 4? 3. And this is getting kind of boring now. N minus 5 is 2, n minus 6 is 1, and finally n minus 7 is 0. In other words, the pattern is that you're subtracting one more each time. So this would be n minus 1, n minus 2, n minus 3, n minus 4, and eventually you would get down to n minus n. In other words, 7 minus 7, which would be 0. So, in a nutshell, if that was still confusing for you, all you really have to remember is that a polynomial should be in order from the largest exponent down to the smallest exponent. It doesn't matter about the coefficient. The only reason why this looks funny, and I made them color-coded here for you, is that you understand that a sub n is attached to the exponent n. And the n minus 1 is the coefficient of x to the n minus 1. And on the story would go. So then a sub 1 is the coefficient of x to the 1. And then your last term is a constant. So again, just remember that they have to be in order from biggest to smallest. That's pretty much all you need to know about polynomials being in standard form. So then we move on to our next screen here. And I want to talk a little bit about the degree of a term versus the degree of a polynomial, because they will ask you for both of these things in the homework. Degree of a term. Let's just put up the examples I had earlier. I think we had a 3, 4x at some point. You could even have 5x squared y, something like that. The degree is basically the exponent of the term determines the degree. So since this one has no exponent, it has no variable, you can call it x to the 0 power, and we know that anything to the 0 power is 1. So that would just be 3 times 1 is 3. So basically there is no exponent. The degree here, though, is 0. We would say that this term has a degree of 0 because it's x to the 0 power. So it's not there. Okay? Also, we'd give it a name. It would be called a constant term, which should make sense because the variable is what means change. You know, variable means variety, changing. Constant is the opposite of that. It has no change. It's always the same. So it's constant. So there's no variable. There's no exponent. So the degree is 0, and it's a constant term. This one, however, the 4x, has x to the 1 power in it. And when it's x to the 1 power, its degree is 1 because the exponent is the highest exponent is 1. And also, it would be considered a linear term. It's not considered a constant term because it's linear, x to the 1 power. And we will give you a chart of that in a few seconds here. Then you have your 5x squared y. And in that case, the degree would actually be 3. You're not going to have to worry about these kinds in this lesson, but I'm just telling you that if you had two different variables, then you would have to add those exponents together. So since x squared is a degree of 2 and y to the 1 power, you would have to add those two together and get a degree of 3 for that term. However, in this case, we're not really going to deal with polynomials that have more than one variable. So you don't have to worry about those kinds, but you do have to worry about these. So again, each term has its own degree, and then that brings us to the polynomials. A polynomial would have something like quadratics, for example. We've done those already. 7x squared minus 4x plus 3. This polynomial has more than one term. There are 3 terms. 7x squared is one term, negative 4x is another term, and 3 is another term. There's 3 terms. This is a trinomial. That's good to know. We'll see that in the next slide here. It's a trinomial, but what's the degree? See, each term has its own degree. This one is a degree of 2 because it's x squared. This term has a degree of 1 because it's x to the 1 power. And this one has a degree of 0 because it has no variable at all. So then, if it has 3 different degrees, what do we say is the degree of the polynomial? Well, we pick the highest. So it's the largest degree of any of the terms of the polynomial. So since there's 3 terms, the largest of all of those terms is the x squared. So this polynomial is degree 2. So I hope that you have understood at this point the difference between the degree of a single term and the degree of the polynomial as a whole. So this polynomial has 3 different degrees for each term, but the degree of the polynomial as a whole is 2 because of the x squared. And standard form tells us that we should put them in order from the largest to the smallest. So this is already in standard form. Alrighty, so we go on to standard form. We talked about it a little bit already. When a polynomial is in standard form, then you list the terms of the polynomial in decreasing order by degree. So again, this polynomial has 4 terms. 2x cubed is one term, negative 5x squared is another term, negative 2x is another term, and 5 is a constant term. So you have 4 terms, and it's already in standard form because you can see that we put them in order from, it's 3, 2, 1, none. So they're in order by decreasing order. So just want to give you some information here. The black over here, polynomial, just represents the whole thing together. We would call it a polynomial. But we have a leading coefficient. When you have the polynomial in order, then the first term is the leader of the pack, so to speak. So 2, in this case, is the leading coefficient. It doesn't matter that the 5 over here is bigger than the 2. You put them in order by the exponents. So the 2 is the leading coefficient, even though it's smaller than the 5. And this is called a cubic term because it has x to the 3rd. And then we have our quadratic term and our linear term and our constant term. And these names are all given to the terms by their degrees. So I'm going to give you a chart. I'm going to give you a few, well, actually I'm not going to give you that long. You can pause the video at this point if you'd like, so that you can have a chance to write all this down. This is basically polynomial classifications. We have over here our columns, degrees from 0 to 5. We have the name that you would use based on the degree. Then we have an example of each kind. And then you have the number of terms and the name that we would give it. On your homework, you're going to be asked to name and classify polynomials based on degree, so this column right here, and based on number of terms, this column over here. So I'm just going to run through it really quickly. If I'm in your way, then you'll want to just pause it and come back and fill it in. But here we go. Degree of 0. We would call a polynomial with a degree of 0 a constant. And here's an example, like we saw before, a number by itself with no variable. How many terms? That's only one term. And because of that, its name is a monomial. So the answer for this example would be a constant monomial. Then we have this guy here, x plus 3. We've got two terms. And since the degree of x is 1, it's x to the 1 power, it's considered linear. And a binomial because it has two terms. Here we have a quadratic because it's x squared, but it's only one term, so it's a quadratic monomial. And then we have this example here. We've got three terms. We've got 2x cubed, 5x squared, and 2x. So there's three terms there. So we have a trinomial, three terms. And it's cubic because the highest degree is 3. And then we have a quartic polynomial here. And it has only two terms. And 4 is the highest exponent. So it's a quartic binomial. And our last one here is a quintic. And it has 4 terms. 1, 2, 3, 4 terms. The highest exponent is 5, so we call it quintic. But it has 4 terms, and you will notice that at this point we kind of run out of names. We've got monomial for 1, 2 is binomial, 3 is trinomial. We don't have a quadrinomial. So at that point, once you get beyond 4 terms or 4 or more terms, you just call it a polynomial, but then you have to say how many terms it has. So a polynomial of 4 terms. So if you had a polynomial with 7 terms, you would have to say polynomial of 7 terms. So here is your chart. So you might want to put that in your notes. And I'm going to move on, but if you didn't have time to write that all down, you can always pause. Okay. So right now I'm going to do a couple of examples for you using that chart. I'm going to do 2 examples for you, and then I'm going to put 3 examples on the board for you, and those are the examples that you need to do on your own and bring them to class, next class period, so that we can make sure that you understood the lesson or that part of the lesson. So here is my first example. Let's make sure I get... Example 1 here is going to be negative 7x plus 5x to the 4th. Now in this particular example, the directions ask us to write the polynomial in standard form and then to classify it by degree and number of terms. So standard form would require us to have the highest exponent first, and as we can see, that's not the case in this problem. So we need to rewrite this as 5x to the 4th minus 7x. Now this is in standard form. That's the first part of what they're asking us to do. So they do in fact want us to write it in standard form. That's the first portion done. And then it asks us to classify it by degree and number of terms. Since the degree here is 4, we're going to call it a quartic. You can refer to your chart from before. It is a quartic because it's a 4th degree. And because there are 2 terms, it is a binomial. So this is a quartic binomial. And that's it. Those are the 3 parts that we need to have for this example. In example 2, I'll show you something else that could potentially happen. And this example is x squared minus 4x plus 3x cubed, and I will get out of your way in a second, plus 2x. Okay? Now at first glance, you might think that this is a polynomial that has 1, 2, 3, 4 terms. It is definitely not in the right order because the x cubed should be first, but it's also not a polynomial of 4 terms, because the other thing that you have to make sure that you do with a polynomial is that all of the like terms have to be combined in order for it to be considered standard form. So right now we have a negative 4x and a 2x, and those are like terms, so we need to combine those into one term before we can call this standard form. So the first thing we want to do is our 3x cubed should be first because it's the highest degree. That takes care of that guy. Then our x squared should come next, and that takes care of that guy. And then we want to combine our linear terms. Negative 4x plus 2x gives us negative 2x. So now that I've combined the like terms, I realize that this is actually not going to be a polynomial of 4 terms, but actually a trinomial, 3 terms only. So this is going to be a cubic because the highest degree is 3, so a cubic trinomial. Alrighty? So this would be my standard form, and this would be my classification by degree and by number of terms. And that's what you're going to be asked to do on your homework as well. And right now I am going to write, I'm going to write some examples on the bottom here of the board, and these are the examples I expect you to have in your notes for next class period. So here we go. There's actually one question, but it has an A, B, and a C. So we have 4x minus 6x plus 5. That's A. B is going to be 3x cubed plus x squared minus 4x plus 2x cubed. That's B. And C is going to be 6 minus 2x to the 5th power. Okay? So those are 3 examples for you to complete in your notes. Again, please remember to make sure that they are in standard form and that you have named them by degree and also by number of terms. Okay, so now we are going to go on to the second part of the lesson, which is a lot of calculator based stuff. So first I'm going to again give you some time to just kind of write this stuff down. These are all the steps that you're going to need in order to use the calculator to model data. So we have here different things that you're going to need to know how to do, how to clear the memory of the calculator, how to enter data, how to plot data. You might want to have to go back and pause this because I'm going to just go through these 3 screens very quickly, and then I'm going to actually show you an example on the calculator myself. So you're going to want to write these down later or pause it to do that. Here we have how you edit the window. Again, more instructions. You can pause this and write those down. We also have instructions on how to get the equation of the polynomial model, which I'm going to be asking you to do in your homework, and also how to graph the model with the data all together. So again, you might want to pause these screens and write it all down. Because right now what I'm going to do is show you how to do this. This is an example in your book. It is on page 302. And what I will do is at least write for you here the actual table. 0, 5, 10, 15, 20. This is 10.1, 2.8, 8.1, 16.0, and 17.8. This is an example in your book. It's on page 302 if you want to have your book while you're taking these notes. And what they're asking us to do in this example is to use a graphing calculator to determine whether a linear model, a quadratic model, or a cubic model best fits the data in the table. So believe it or not, this is a completely calculator-driven problem. So at this point, I'm going to run over to my calculator screen here. I'm going to turn off these lights so you can see it better. That means I might get kind of dark, but don't worry, I'm still here. And we are going to go to the calculator. Okay, so again, all of these steps I've given you on those screens earlier. So right now I just kind of want to make sure that you can follow with me. The first thing that I asked you to do on the calculator was to clear the memory of the calculator. For example, you might start this process by hitting the Stat button. And when you get to the Stat button or screen, you have this menu of, Edit, Calc, and Tests. The first thing we have to do is edit. And as you can see, there's already data in there. So if that's you, you want to make sure that you clear the calculator's memory. So I'm going to show you how to do that. So you're going to hit second, the second button on your calculator. When you hit second, there's a little arrow in the top right-hand corner that tells you that you hit second. And then I'm going to hit the plus button, which is the addition button on your calculator. And you're going to come to this screen where it says clear all lists. Okay, and that's what I want to do, which is option 4. So I'm going to clear all those lists and hit enter to do that. Now, when I go back to stat, by hitting the stat button, and I hit edit, there's nothing there. It's all cleared. And that's how you want to get started, with everything cleared. So now I'm going to enter the data from this example, which is on page 302. And it says that the x values are 0, 5, 10, 15, and 20. And I enter all of those x values in the L1 column. Then I'm going to enter all the y values in the L2 column. And the y values for this example are 10.1, 2.8, 8.1, 16.0, and 17.8. And so now all of the data is in the calculator. Now we're going to ask the calculator to actually graph the data. Okay, so again, I am going to go to my graph here, and pardon me, I didn't want to do all that. Let me just clear some of these things for you so we can start from scratch here. My calculator has other equations in it right now. But when you hit graph, it's probably going to look like this. You're not going to have anything graphing, and your grid's going to be right down the middle. But to plot the data that you just put in the calculator, we're actually going to go to this thing called stat plot. And to do that, you hit the second button again, and there you'll see my arrow for second. And I'm going to hit the y equals button, and you'll get to this menu, and it says stat plots. And there's several stat plots. We're only going to use one right now. And so we're going to go with the first one. So we hit enter, and we're going to turn it on. You will notice that it's off right now because this is dark. The word off is darkened. So we're going to hit enter to turn it on. And then you have to just double check that your X list says L1 and that your Y list says L2. If it doesn't say that, then you're going to have to come see me and I can show you how to fix that. But hopefully you guys are all good to go there, and we're going to hit graph. Okay, now when you look at this graph, you only see two little dots here, or markings for the data. And our original data actually had 1, 2, 3, 4, 5 data points. So I can only see 2 of those data points. And the reason why that's happening is because your window is not allowing for us to see them. You will recall that the data on the lists that we did, if I go back there real quick, the data went from 0 to 20 on the x-axis, and for the y-axis, the smallest data was 2.8, but the largest data was 17.8. So the problem is that when you look at your window on your calculator, it's going from -10 to +10. So it's not allowing you to see those extra data points because your window's not right. So we're going to show you how to fix your window. Again, these settings, the instructions on how to change your window are also in those screenshots that I gave you earlier. So you can go back and look at those if you need to. But here we go. To edit your window, you have to hit the window button that's on your calculator, and you come to this screen. And for the X-min, you basically want to enter the smallest X value in your data set, or somewhere close to it. So the smallest X value for us was 0. So I'm just going to go to starting at 0, and we're going to go all the way to, I believe it was 20 was the highest. So I'm going to go to 25. And in fact, I'm going to go back here and make this -5. I don't want to start on 0 because my smallest data is actually 0. I want to go a little bit before it. So I'm going to go to -5 to +25. My X scale is going to be 5, which just means that it's going to go 5, 10, 15, 20, 25, and instead of doing 1, 2, 3, 4, 5. For my Y, the smallest Y value we said was 2.8, I believe. So we can start at 0. And the highest value was 17.8, so we can go to 20. And again, we can go by 5s. So then when you graph it now, when I hit graph now, you can actually see all 5 data points. There's 1, 2, 3, 4, 5. They're all there in our window because we adjusted the windows to fit the data. Okay, so now what you want to do is actually find these models. We were asking you to find a linear model, a quadratic model, and a cubic model. So the important thing there is that you have to do it one at a time. Do not do more than one at a time. So I'm going to walk you through how to do this. So the first thing is I'm going to go back to my home screen, which is by hitting second and then the mode button, which is the quit. So now I'm back here to my home screen, and I am going to hit stat. This is the same place that we entered the data. And this time, instead of editing, I'm going to go to calculate by using my arrows to move over to the calculate menu. And you will see that there are 3 options here. There is linear regression, quadratic regression, and cubic regression. There's even quartic regression. But right now, we're only interested in linear, quadratic, and cubic. These 3 right here, options 4, 5, and 6. We're going to do one at a time. We're going to start with the linear, so I'm going to hit 4, excuse me, and enter, and it gives me the values. This is your mx plus b, and it tells you what the m should be and what the b should be, okay? And then the calculator will take that data and it can store it into your y equals menu. But again, you have to do these one at a time. Don't do them all at the same time. So what that means is I'm going to go to y equals, and hopefully your y equals menus are all empty. There shouldn't be anything there. If there is, you should clear them out. So here's my y1, and it's blinking in y1. So now I'm going to go to the vars button, V-A-R-S, vars button. And when I go to vars, which means variables, I'm at this screen, and I want to go to option 5, which is statistics. And then I'm going to go to EQ for equation, using my arrows. And then I want option 1, regression equation. And what the calculator will do is it will take the current regression model that you just did and store it in its memory and then put it in your y1 for you. So there it is, 0.572x plus 5.24. It's going to store it for you. But it only stores one at a time. So that's why I'm saying you have to do it one at a time. You can't do this all at the same time, all 3 at the same time. So then when I hit graph, there's my data. You can still see my data. And this is the model. And it's not really a good model because a lot of the data points are not even on the line. But it is a model. So there's my linear model. Now we're going to go and do the quadratic model. So we do the same thing all over again. We're going to go stat, calc, and this time we're going to go with option 5 and enter. What now has happened is that the calculator has erased the linear model from its memory and now has the quadratic model in its memory, which is why, again, you have to do these one at a time. So now I'm going to go back to y equals, and this time I don't want to delete my y1, but I want to put both models in the same graph. So I'm going to move my cursor down to y2 and do the same process again with vars, option 5, equation, regression equation, enter. So now you'll see all these numbers here, but it's basically stored the equation there. So now we have y1 and y2. And when I hit graph, there's my quadratic model. It's starting to get a little bit better. It went through one of the points. It's pretty close to those 2 points, but it's still not the greatest. Okay? So the last thing you want to do is the last model. So we go back to stat, calc, option 6 for cubic, hit enter. It's now stored that in its memory. So we go to y equals, and now we want to go to y3. There's my y3. Once I'm there, I hit vars, 5 for statistics, EQ for equation, enter, enter, graph. And now you can see all 3 models, and it's very obvious that your cubic model is the best model. It's going through all of the data points, as you can see there, and that is your best line of fit or your best model. And that's what the example is asking you to do. Alrighty, so again, you have some examples to do on your own. I'm also going to add to that the example number 3 on page 302 for you to do as well. I want you to find the same type of information there, okay? And that should be your lesson for today. Thank you.